Okay, everybody. So, like we talked about on Tuesday, if the list of transformations has a dilation in it, then the final image is similar to the pre-image, right? And if there isn't a dilation listed, then the figures are congruent. I could give you 150 different transformations on something. And if I don't tell you that it dilated, the final image is congruent to the pre-image. Okay? So it doesn't matter how many different items are in our list. The key word you're looking for is dilation. If any single one of those is a dilation, then it automatically no longer becomes congruent and it becomes similar. Okay? All right. So something else we have to train our eyes to do is to look at a picture like on problem 2A here, okay, and determine what transformations I did on the pre-image to get the final image. All right? Kind of like what you were doing a little bit with Fire Up today.
Teachers, pardon the interruption. Sixth grade teachers, you can go ahead and end your testing session now. Please make sure you fill out your absent forms and do not finish. We will come around and collect your envelopes. Thank you.
Okay. All right. So, color code. Okay. Color code it. Let's see what we can do. Sometimes color coding it, as you know, will help us figure out what's going on here. There's also some other clues that could help you out too, and I'm going to show you, take you through those also. Okay, you guys ready to go? I want you to talk about it in groups, okay? What two transformations do you think I did on the pre-image to get the final image? And note that they are congruent, okay? That should help you out a little bit. Good.
I think he still rotated it around the center point, but yeah, he also like
Remember, you can also physically interact if you have to, or slide it, whatever you need to do. See what's going on, okay?
Turned it 90 degrees, and it looks a little bit off.
What's up, Chloe?
So he did.
Why not?
He did it counterclockwise. Oh, he didn't slant it. I think he turned it clockwise. He just completely turned it clockwise. Oh, wait, no. Because he went counterclockwise 90 degrees.
Are you sure? Okay.
And
That's it. Last time I copy and pasted the same thing.
could have also
It'll be a fill transformation.
rotated it
Copy paste. That's the best transformation we're going to talk about.
70 degrees. What?
Copy paste. I've been on computer copy paste, but I told Lily, I said, I think they're the same because when I copy and paste today, I resized it. So
Yeah, like if you so we're not going to he's doing it clockwise, this 90 degrees, but
And the physics tool and notabilities like slide is code.
okay, you guys getting it figured out? You have to kind of detect it. You have to put your detective skills to work here, right? Okay, you guys think you got it figured out? Or do you need a little more time? More time? I think you got it. Maybe.
We got some of it.
You got some of it. Well, I'll take some of it. That's good. Okay. This is not easy stuff until you kind of get more trained into figuring out what you're looking for. Okay. So that my job today is to train you guys a little bit on what to look for, so then these become a little bit more manageable. Okay. Because the colors should push up a little bit too. The color code and everything that should help. Because what did you guys notice right away when you started color coding? Did you guys identify at least one transformation for me? Okay, so which one did you identify right away? Raise your hand for me. Okay, Lily? Yeah. Yeah, there's a definite rotation. Look, the placement of C here, okay, let me mark it here on the picture so I can show the people that are watching the video too. Okay. If I didn't turn the figure, then C that's right here would have been C there too. Okay. But I definitely did a turn because the blue is not in the same position on the final image as it is on the pre-image, right? Okay. There's another big giveaway here too, kids. That's a point of rotation. Okay. So if you see a point on your picture like that, that's a rotation point. Okay. So that's a giveaway that there is a rotation involved. Okay? Are we good with that? Good. Okay. Definitely a rotation. Can anybody figure out how much in which direction? Okay, clockwise is this way. Clockwise is that way.
I was thinking of it differently. I had the top one facing the other way. I just didn't.
Okay.
I marked it.
Counterclockwise, yeah. Okay. What do you think the next one is then? I got an idea here. Let's see if this works. Oh, it didn't. Oh, hold on. There we go. That's what I was looking for. Okay. So here's the deal. If I rotate it, that's what would happen, right? That's about where it would be. Okay. So you see what I just did? So you could do the same thing. I did a select, but then when I pasted it as an image. So then it didn't just paste the highlight, okay, or the notability pin. It pasted the shape as well. Okay. Pretty cool trick. Because then what do I do to get here? Slide. Okay? Translation which direction, kids? Translation right. Okay? Done. Okay? Everybody good with that? Show me a thumb. Okay? So use your tools to your advantage here on this, okay? And if you're on the coordinate plane, that helps a lot too. All right? So you can use the coordinate plane to help you out with these also. When they're on the coordinate plane. We're going to get to some of those here in just a minute. Okay? All right. So, how about now that you guys are all a little bit warmed up, you guys all try beat together. Okay? Discuss it. Come up with 2 transformations. Color code it first. And again, if you color code it, it'll help you figure out some of the relationships here. Okay? There. Okay. You guys want to work on your own, then discuss it with your group mates? Okay. Go ahead. All right. Go right on ahead. Nosy. Don't have to worry about that when it's on the board.
Oh,
Just tell me it's an enlargement or reduction.
okay.
Okay, that's it, yeah. Okay, the guys for dilations, okay, on off the board of plan, you don't have to identify the scale factor, that's impossible, okay? Just tell me if it's an enlargement or a reduction. Good question. All right, everybody got the two transformations on this one? I haven't rolled these dice in a long time. I haven't even rolled these dice here today.
Architects would use this.
Yeah, oh, definitely.
I feel like this is what architects would use.
I actually used this morning working on another project for next year. I was working on a project, updating some stuff for next year, and I was actually thinking, gosh, I just did a rotation on this. Or yeah, I just flipped this. So yeah, it happens. It's one of those things that happens when you're not thinking about it. I'm glad not. Okay. I'm gonna roll. Let's see what you guys can do, okay? I think it's not like a buck. I'm gonna roll the dice and do it straight ahead. Okay, let's roll. Okay, so let me see if that person's here today. Tris. What's one of the transformations on the pre-image? Yes. Mm-hmm. And again, when we're off the plane, this is not necessarily the y, it's just the line. So we just say reflection over the given line. Okay? So reflect over a line, you rotate over a point. Those are big clues. Okay? So if you see an arbitrary line right there, guess what? That's a line of reflection. If you see an arbitrary point somewhere on your picture, that's a point of rotation. Okay? Those are clues. Right? Big clues. That'll tell you what's going on. I agree. Okay? That is a reflection. Okay, over that line. Did anybody figure out the other transformation? Okay, Madeline. Did I reduce or enlarge? Very good. So the question becomes, what order do I write these in? Do I have to write it in that order?
The reflected shape is not.
Hmm.
The reflected shape is not normal.
Well, it starts with WXYZ, so WXYZ is the original size, and then it reflects, and then it could be from.
Or could I reduce it first and then flip it?
Yeah, that's what I do.
No, because it's not reduced.
But could I reduce it first and then flip it over on the reflection line?
Because then it's still big.
Then it'd be this shape right here.
But then it's still big, so you can't do that.
Why not?
Because it's still
Because there's not an extra step that's given.
I'm not doing an extra step, I don't think, am I?
But yeah, because an extra step would be making it bigger again.
Well, why would I have to make it bigger again?
Because then,
because it's big as it is. It's big on the page.
yeah.
Let's go over here for a second, okay? Quick little triangle. Let's do 2, 1, 4, 1, and sure, 3, 2, okay? Okay, so there's my triangle, right? So there's A, B, C. Now, if I reflect that over the x-axis first, then I get A prime, B prime, C prime, right? Okay, and then if I dilate it, and I wanted to dot that. Okay, so then if I dilate it, then A, which was well, A prime, which was 2, -1, going up as scale factor 2 become 4, -2, right? And you just multiply everything by 2. Okay, so then that would put me right there. Okay, now here's the thing, all right? Let's say I go ahead and dilate it first. Okay, so up here, A is the 0.21, right? What if I dilate it? What will it become? 4.2. Okay, so then if I plot the 0.42 and then reflect it, guess where I am? Same point.
Well, just to explain what that one's big and that little.
You can shrink it first and then reflect it, or you can reflect it and then shrink it.
Why is that one so big?
What do you mean?
Because if you shrink it and then reflected it, that one's still.
But you don't see that middle. You don't see that first transformation on your page. It's just like over here on this picture. You didn't see the rotation, did you? No. Okay. So here, it's not showing you the actual reduction. But that's what you're going to do first to it. Okay. It's not showing you that in the picture. What it's showing you is that after you reflect it, or after you reduce it, it's going to be in this shape right here. But the order in which you do those doesn't matter. And that's what I was trying to prove over there on the board. Okay? It doesn't matter sometimes it doesn't matter which order you do the transformations in. Other times it does matter which order you do the transformations in. Okay? So either way, if you had the list correct, you would have gotten full credit for it. Okay? So if you had a reduction and then you had a reflection, that's fine. If you had a reflection, you had a reduction, that's also fine. Okay? So it doesn't matter. That's what I was trying to say. It doesn't really matter. Make that difference. Can you see that now? Okay, good. Let's write it down and move on. Okay. Reflection over given line, and then reduction. Okay. Should I try it again? This one on the coordinate plane, maybe? You want to try to figure it out yourself before you talk to your group mates? You want your group mates' help? Want to go solo? Okay. Let's go solo. This time, now we're on the coordinate plane. Okay. Let's look at problem 3. You want to go ahead and do B2 while you're working on them and get them both knocked out? You're talking about both of them when you get talk to your group mates again? But you're knocking both out. Okay? colors up and see what you can figure out. And I'll tell you what, on part A, the order does matter. Okay, so the order matters on problem A. Okay. Are you doing okay? Very good. Get some things deciphered here. The prime notation for final language with the apostrophes. Okay? Yes, it does matter. Because especially like the annihilation, it tells you what your scale factor is. Okay? So yeah. On B, you guys can determine your scale factor because you have ordered pairs that we do that. Okay? Alright? And like you know what your reflection line is, you know what your rotation point is, you know how much you translate. So you can be more specific with these. Okay? And we expect you to be more specific if you're on the court of final assessment. Okay? With all the different attributes. Thank you very much. Okay, start talking about it, okay? I think this is going to be our last problem for today. We'll finish this up then on Monday, okay? We'll start discussing this, so what you guys can come up with on these.
When do you usually get out of math class?
All right, so I pasted the triangle, okay? That might help you out a little bit on A. Were you able to figure out what the two transformations were? Good, 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 good. Lily, what was one of them? Yeah, see, that's why I put this like I call it like the halfway image on that, because if you move that up to the y-axis, you can tell it was reflected over the y-axis. Okay, good, 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 good. Okay, that's actually what has to be listed first on this one for it to probably work out the best. Okay, Charlie.
I did it a different way.
Okay.
Not the same, but I reflected it and then slid it down 3 and left 4. Does that work?
You mean you reflected it where it was and slid it down 3 left 4? Yeah, that
Like this.
yeah, that should do it. Yep, that also works. Yeah, it depends on which shape you're reflecting. Now, Charlie, the only issue with that is that you reflected the final image, not the pre-image. Okay, and that does make a difference. I'm sorry, I have to take back what I just said.
Yeah, that's what I did.
Okay, so then everything will be in reverse. Okay, all right. Then what was the other transformation then? Maren, do you have it? There's a translation. That's okay. Do you know how much? 4 to the 4 left, I take it? Okay. So, yeah, and here's the thing also. You can also, on these graphs, okay, you can plot in, like, what the shape would look like after its first transformation to see if you're on the right page, too, okay? So, like I did it right there with the triangle after I reflected it, okay? So that's a trick you can do also with these, okay? That can help out a little bit. Did you guys get B figured out, too? Good, good, good. Abby, did you figure out what one of the transformations was on B? Okay. Do you know how much in which direction? Okay. So definitely looking at from Q to Q prime looks like I did a turn. Okay. Because Q prime is now not, if I didn't turn it, then Q prime would have been here at the R prime position. Did everybody see that? Okay. So definitely got a turn there. How many quadrants did you pass? 1. Each quadrant adds 90 degrees. Okay. That's a 90 degree kind of clockwise rotation. And again, remember, if you can identify with just one corresponding pair of vertices, it applies to all the others as well. So if you can identify it for one pair, then you have it for all of them. Okay? So just focus on one pair then. So we're going to do a rotation, 90 degrees, counterclockwise. Okay? And then what was the final transformation on this one? Okay? Lily? Yes. By how you know what the scale factor was? I get Q being 6, -2. Does that look good for you guys? No. I'm sorry, -6, -2. Are you good with that? Those coordinates for Q? Okay, let's compare it with Q prime. Okay. So for Q prime, I'm sorry, that's -5, -2. My mistake. I can't count today. Okay. So then for Q prime, I got the point. It's like 4, -10. Okay. So here's the deal. Since you turned it, okay, only 90 degrees, you have to kind of compare it diagonally here. Okay. So what did you do to the -2 to get 4? What did you multiply by? 2. So it's a scale factor of 2. Everybody okay with that? So that's how you can kind of compare your scale factors there and figure out what, or your coordinates there and figure out what the scale factor is. We'll practice this more, okay, on Monday. Start your next assignment, but we're probably not going to submit it until Thursday, okay, next week. Sound good? If you haven't started any of them yet, get them done because it's coming up quick. All right. Good job, everybody. Not yet.